Welcome to Technosphere, your gateway to the latest in technology and innovation. Today we're diving deep into one of the most revolutionary advancements in computing: quantum computers. What are they? How do they work? And why are they so important? Stick around to find out. Computers have become an indispensable part of our daily lives. But what if I told you that the computers we know today could soon be outpaced by a new breed of machines capable of solving problems that would take classical computers millennia to crack? To understand quantum computers, let's start with the basics. Classical computers, like the one you're probably watching this on, process information in bits. These bits can be either a 0 or a 1. But quantum computers? They use something called qubits. And here's where things get interesting. A qubit can represent both 0 and 1 simultaneously thanks to a phenomenon known as superposition. Imagine spinning a coin in the air. While it's spinning, it's both heads and tails at the same time. That's a bit like what a qubit does, but in a quantum state. But it doesn't stop there. Quantum computers also harness another phenomenon called entanglement. When qubits become entangled, the state of one qubit is directly related to the state of another, no matter how far apart they are. This interconnection enables quantum computers to process enormous amounts of data simultaneously. Now let's dig a bit deeper into how quantum computers actually work. At the heart of these machines is the quantum processor, which is cooled to near absolute zero temperatures. This ultra-cold environment is necessary to maintain the delicate quantum states of the qubits. Unlike classical computers, which solve problems step by step, quantum computers use quantum algorithms to try many possibilities simultaneously. This is called quantum parallelism, and it's what gives quantum computers their incredible potential power. For certain types of problems, like factoring large numbers or simulating molecular structures, quantum computers can be exponentially faster than classical computers. Imagine trying to find the combination to a lock. A classical computer would try every possible combination one by one, but a quantum computer could effectively try them all at once. So, what can quantum computers actually do? The real-world applications of quantum computing are vast and could transform many industries. Take pharmaceuticals, for example. Developing new drugs often requires simulating the interactions between molecules, a task that is computationally intensive. Quantum computers can simulate these interactions at a level of detail that classical computers simply can't match, potentially leading to the discovery of new drugs and treatments much faster. In finance, quantum computers could optimize portfolios and manage risk in ways that are currently impossible. By processing vast amounts of market data and testing different scenarios simultaneously, they can provide insights that could revolutionize trading and investment strategies. Cryptography is another area where quantum computers could have a major impact. Today's encryption methods rely on the difficulty of factoring large numbers, a task that would take classical computers millions of years. But a sufficiently powerful quantum computer could break these codes in a matter of seconds, which is why quantum-safe cryptography is an area of intense research. Quantum computing sounds like a miracle technology, but it's not without its challenges. One of the biggest hurdles is something called decoherence. This occurs when the delicate quantum states of qubits are disturbed by their environment, causing errors in calculations. To combat decoherence, researchers are developing error correction techniques, but this is a complex and resource-intensive process. Unlike classical computers, where error correction is straightforward, quantum error correction requires many additional qubits just to protect the information stored in one qubit. Another challenge is scalability. Building quantum computers with a large number of qubits that can perform practical tasks is still a work in progress. Most of today's quantum computers have only a few dozen qubits, far short of the millions needed for some of the most powerful applications. Despite these challenges, the future of quantum computing looks promising. Companies like IBM, Google, and Microsoft are investing heavily in quantum research, and we've already seen some significant milestones. In 2019, Google announced that its quantum processor, Sycamore, had achieved quantum supremacy, solving a problem in just 200 seconds that would take the world's most powerful supercomputer thousands of years. While this was a proof of concept rather than a practical application, it marked a significant step forward. Looking ahead, many experts believe that within the next decade, we could see the first commercially viable quantum computers. These machines could solve problems that were previously thought unsolvable, leading to breakthroughs in fields like artificial intelligence, material science, and more. At this point, you might be wondering, how does quantum computing affect me? While it may seem like something out of a science fiction novel, quantum computing has the potential to impact everyday life in profound ways. From optimizing the energy grid in smart cities to enabling more personalized medicine, and even addressing climate change by modeling complex systems, the ripple effects of quantum computing could touch many aspects of our lives. As our world becomes more interconnected and data-driven, the limitations of classical computing are becoming more apparent. Quantum computing offers a way to overcome these limitations, providing the computational power needed to tackle the challenges of the 21st century and beyond. Quantum computing is still in its early days, but its potential is enormous. As research continues and technology advances, we may soon find ourselves in a world where quantum computers are as common as the classical computers we use today. If you enjoyed this deep dive into the world of quantum computing, make sure to like this video, subscribe to Technosphere, and hit the notification bell so you never miss an update on the latest in technology. Thanks for watching, and see you in the next video.